Let's talk about digital signal processing. Now, before we talk about digital signal processing as a whole, let's first consider what a signal is. Now, a signal is a function that represents what the variation of physical quantity with respect to what any parameter. Now, there are two things we need to note down from this definition. The first thing we have here is what variation. We need to note down what variation talks about, and we need to consider the parameters as well because we are talking about parameters. So what are the parameters we will be talking about when we are now considering what a signal is? Now the first thing we have there is what variation. Now when we are talking about variation simply talks about what change. So there must be a change before a signal will what occur. Now the next thing is considering what parameter is when we are now considering what a signal. Now we have two parameters when we consider signals, and the first one is what we call time, while the second one is what we call the distance. So basically we are going to consider time interval and what the distance of a particular what signal. So we are considering time and we are also considering what distance when we are now talking about what signals. Am I communicating? Now let's take down an instance. If we have f of x to be equal to ax square plus what bx plus c. What you simply interpret, how can you interpret what we have here? You can simply interpret this by saying what we have a dependent function, and that dependent function is dependent on an independent variable. So basically x here simply stands as your what, your independent variable. Independent variable. Now, in essence, your time and your distance are basically what? Independent variables, or independent, they are independent what? Parameters. Am I communicating? So if you have this to be your what? Your independent parameters, all other function will be dependent on your what? Time and what? Distance. So basically your f of x here simply stands as your what? Your signal. Your f of x simply stands as your what? Your signal. While ax square plus bx plus c simply stands as your what? Your variable of interest. So you have ax square plus what? Bx plus c simply stands as your what? Your variable. Am I communicating? Now let's take down an example. If you have a thermometer, we all know what a thermometer is. We know that the thermometer is used to measure what? The degree of what? Temperature, or is used to measure, yes, anything concerning temperature. We use thermometer to measure it. We have other tools that we use, but let's consider thermometer in this case. Now let's say you at 8 o'clock, you wake up by 8, you had a water and you wanted to heat that water. Let's say at that time, 8 o'clock, let's say at 8 a.m., you woke up, you had your water to be very warm, let's say 14 degrees Celsius. We have your water to be 14 degrees Celsius. Now, by 8:30, you hit that water. 8:30 a.m., you hit the water, and the water becomes 90 degree Celsius. Now, what can you see? You can see a variation. You can see a change in what degree with respect to what the time interval. Am I communicating? So, what you are seeing here, one, you are seeing what variation, and two, you are now seeing what time interval. Am I communicating? So in this instance, you can see that a signal has occurred, right? Because the two things we talk about when we are now considering signals is what we have variation, and we also consider what time is. Am I communicating? So you can see that signal has what has occurred. But in electrical engineering, we consider signal to be the variation of what we consider signal to be the variation of what electrical quantities. So in electrical engineering, let's say in engineering, electrical electronics engineering, we now consider signal to be what the variation of electrical quantities. Electrical what? Electrical quantities. Now what are these electrical quantities which we consider? They are basically what? Current and what? Voltage. We're now going to consider what? Current and voltage. And this current and voltage, they are what? They are the electrical quantities which we would consider. So what we are considering is, you're basically considering what? Time and voltage over a particular time interval, or over a particular what? Period of what? Time. Now that time we are considering, the time interval we are considering is basically what? Our what? Independent what? It is our what? Independent what? Quantity, right? So if you're now considering current and voltage over a particular what? Distance, or over a particular period. The period there simply talks about what? Distance. But when we are now considering time interval talks about what? Time, right? So when you are considering period over a particular period, period here simply talks about what? Distance, and distance is also what? An independent what? An independent what? Quantity. Am I communicating? So basically, in electrical slash electronics engineering, when we are considering signals, we are basically considering what? Electrical quantity, which has what? Which are the what? Current and voltage. And we are now considering to any parameter which we discussed earlier, and that parameters are what? Time and what? Distance. Am I communicating? Now let's take an instance. If you have a current, if you are now asked, a current remains what? Constant for a different time interval, then do you have a signal? If you're now asked, if you now ask that a current, let's say current remains what? Constant at different different time interval, then do you think you have a signal? Is a question. So drop your answer on the comment section. But let me answer this. If you have a current remains what? Constant. When I mean constant, let's say if you have one, then when you go to a particular time, you still have that one. This is constant, right? But when we're now considering signals talks about what? Variation. So there should be a what? A change. So if you're not having this concept here, then basically what? There is no what? Signal. Because when we are now considering what? Signals, we are not referring to constants, but we are referring to what? Change. And that change stands as our what? Our variation. Am I communicating? So in this question here, it's simply what? No, there will be no what? Signal. Am I communicating? Is that answer the same on your comment section? Simply say what? Yes. Let's consider a transducer. A what? A transducer. Now take down transducer. Transducer. Now, what's a transducer as an electrical component? A transducer is basically a device used to what? Convert non-electrical signals to what? An electrical signals. So the work of a transducer is basically converting non-electrical signals to electrical what? Electrical signals. Now let's take an instance, or let's take an example. Now, when we are now considering a transducer, where can we actually take this instance from? Okay, let's say you are in the church. Let's take a church setting as a case. Let's say you are singing in the church. Now, you singing, you require what? A microphone, right? So basically, this is you. Let's say this is Bola. Now, Bola is actually a singer, and Bola needs a what? A microphone to sing. A microphone to sing that song that he loves singing, right? Now what happens is the sound creates what? When Bola is singing, the sound that enters the microphone creates what we call a vibration. A what? A vibration. So what happens is, when you sing, when you make a sound, that sounds in the microphone becomes what? Vibration, right? And what happens? That vibration is now converted to what? An electrical pulses. So what happens is, your vibration will be converted to what? Electrical what? Pulses. Electrical pulses. Electrical what? Pulses. and those electrical pulses will be amplified in the what amplifier, right? So if your electrical pulses, you have your vibration converted to what electrical pulses, and what happens to your electrical pulses? Your electrical pulses will be what your electrical pulses will be amplified. They'll be amplified in the what amplifier, right? And that amplifier sends what that signal to the speaker. So your amplifier sends the signal to your speaker, and that's where you will now hear the beautiful song that Bola or Ahmed is what singing. I come again. Now, if this is Ahmed, let's say this is Bola, sorry, this is Bola, and Bola wants to sing a song in church, what happens is they'll give him a microphone, right? Now, after giving him that microphone, Bola is going to make his or her own sounds on the microphone by singing. Now, what happens on that microphone is that microphone on the microphone, what happens is there will be a vibration that will occur while Bola is singing. Now, those vibrations will act as what electrical what pulses, and those electrical pulses will be sent down to the what it will be amplified and sent to the what amplifier. So what happens in the amplifier? The amplifier amplifies the sound and moves it down to the speaker, where you now start hearing the beautiful songs Bola is singing.